Quantized networks can be achieved by embedding quantization functions to quantize weights as well as activations. Quantization function involves a rounding function which is non-differentiable. In order to backpropagate through quantization function, STE approximator is generally used. STE approximates gradient through quantization function as identity. STE approximation leads to oscillation issue during training of quantized models. This work, instead of usual image classification task in quantization literature, we look at the problem of quantizing networks for downstream tasks using single shot detectors like YOLO5 and YOLO7. We first illustrate the oscillation issue using toy 3D regression example using LSQ and ST. As can be seen, not only latent weights, but scale factors for both weight and activation are affected by oscillations in QAT. We further show oscillation issue is also prevalent in YOLO networks. Most of the latent weights hang at the quantization boundaries even at the end of the training. Also, quantization scale factors are not stable even until the end of QAT. Further, in order to check whether weights at the quantization boundaries are suboptimal, we design a pseudo soft rounding function that quantizes weights only within certain threshold to the quantization level and leave weight at quantization threshold in their latent state. We notice that soft rounded models performs consistently better than hard rounded models, even though QAT is performed using hard rounding. This indicates some latent weights oscillate due to their optimality at quantization threshold. To deal with oscillation issue, we propose two methods: exponential moving average of model parameters and quantization parameters aids in finding most suitable weight and scale factor by keeping track of last few iterations. Quantization correction is aimed at estimating correction factors that can reduce the error induced by oscillating weights and scale factors. We embed these correction factors gamma and beta after all convolution layers and optimize them for a single epoch after we have performed QAT. We compare our method against baseline LSQ and oscillation dampening method. For all smaller variants of YOLO5 and YOLO7, our method significantly outperforms the baseline. Also, our method is applicable for all recent YOLO variants, irrespective of the size of the model. As can be seen here, it significantly boosts quantization performance for both 4-bit and 3-bit quantization. We also evaluate our method for task of semantic segmentation using YOLO5. Both at 4-bit and 3-bit quantization, our method outperforms the baseline method. In summary, most of the QAT literature focuses on image classification tasks, but in this paper, we focus on single shot detection and segmentation networks like YOLO. We show that recent YOLO variants, YOLO5 and YOLO7, suffer from oscillation issue due to the STE approximator. To solve the issue of oscillation, we propose EMA, which is exponential moving average, and post hoc quantization correction as a solution to recover the error induced by oscillation phenomena in quantized YOLO networks. Our proposed approach yields state-of-the-art quantization performance on YOLO5 and YOLO7 at low precision for both object detection and semantic segmentation tasks.